Hey, physicists, what's the crack? So again, what we're doing is some paper 3, section A about radiation, okay? So this one again is asking us what we're trying to do is trying to figure out how much radiation comes out of this source. And what we're doing is we're seeing how it affects the inverse square law. So what we're doing is we're seeing how the distance affects the radiation that we count, okay? So what it wants us to talk about is why might the thing that we record, might the count rate not be the right reading, why is it not accurate? And the other thing we want to talk about is safety, okay? So the first thing we'll mention is our safety. So points for safety you want to think about is that we make sure the source is only in the room when we're taking our readings, okay? So source is only in the room when recording readings, and the reason why is that we minimize exposure time of the humans, okay? So I want to minimize your exposure time. Another thing you want to make sure is that the sealed source is never pointing towards you. So never look at or never point the sealed source, or a better word, because it's sealed right now, but you're going to have to take it out to do the reading. So never point the open source at the person or at their eyes, okay, and again for safety. And another thing you want to do is just make sure when you're taking your readings that you want to stand behind a lead shield, right, because lead minimizes the amount of gamma. So again, you want to stand behind a lead screen. So again, for a 3-mark question, you obviously don't have to mention all of these, but there'll be marks for each one of them. And sometimes for different papers, they might have already given one of these to you in the questions, so you'd have to use a different one. So just all there for you so you can revise them, okay? The other thing then we want to talk about is why might this count rate not be right? Okay, the count rate might not be right because what we're doing is we're using radiation, okay? We know that radiation is random, and you get a mark for saying that. So radiation is random. So what that means is we can predict how likely it is that some type of radiation will come out. But again, it's just a prediction, right? Like if I flip a coin, I can predict if I'm going to get heads or tails, but I can't guarantee it's going to be a heads. So because it's random, it might be that if I'm recording for 1 second, which is not good to do because we should record for a big time, but let's just say we did record for 1 second, I might get 0 count rate because there might be no radiation emitted, or I might get lots of count rate because there might be lots of radiation emitted in that time, okay? Because again, the radiation is random, okay? Another thing then with a problem that is called the dead time. So the dead time in our counter. So what actually happens is when some of this radiation is emitted, what it's going to do is going to ionize the gas in this chamber, and then the ionization causes a current to flow, which is called a count rate, okay? So the dead time is the time it takes for that charge to pass for another charge to be created. So because of the dead time, if any radiation hits that Geiger tube, so if any radiation hits my detector, within that dead time, it's not going to be recorded. So if any radiation hits the detector within the dead time, it is not recorded. Okay. And the final thing to write about, the final problem that might be, is again, we don't know what type of radiation is coming out here. Okay. So we know our free type of radiation is our alpha, our beta, or our gamma. Okay. If it's alpha radiation, we know alpha radiation is the most ionizing. And because of that, it can probably only travel about 5 centimeters in air. So if we're using alpha radiation, it probably won't even reach the detector because it's going to get absorbed with the air between the seal source, between our open source, and our detector. Okay. And one last thing we didn't mention in this question because I didn't ask it, but just because we have up here. Another thing, it's really hard to measure the distance between your sealed source and your detector because you don't know exactly where the ionization is going to occur. So your value that you record for distance when you're recording the inverse square law is probably not going to be accurate either. Okay? So there's all your possible problems that can go wrong in this equipment or this experiment, and they ask quite different questions about it. So just remember to be aware of all of them. Okay? So that's grand.